Now we are looking at some special things that can happen with qqplots. So one thing is a qqplot can detect outliers. Here we have normally distributed data, but then one point jumps way off the limit up here. And this point is an outlier. If we remove this point, fit the model again, then we get this qqplot, which looks very good. Yeah. So this is normal, and this is also normal, but it has one outlier. Note that the line here, the slope of the line shifts a little bit. This is due to this one outlier, but it's still normally distributed. Okay, that was one special case. Here we have another thing you can do with qqplots. You can detect mean shifts. By mean shift, I mean something like a regression like this. I have some x variables here, and one of them is an indicator. So it's x3 is an indicator that was turned on for about half the observations. That was exactly when the observations here, for this half, right? And if you run a regression but omit the indicator variable, and assuming that the indicator variable mattered, so you can see it, then what you see is a shift in the means. It just jumps up. Notice that we have also a different angle here, right? The slope is smaller than the regular slope 1 here of this green line, and the same here. And down here we have what could be 2 outliers, or yeah, it's sort of unclear once you take the mean shift out whether these would be still outliers. Okay. Yeah. So once we fit the revised plot on the next page, we get the following. So this is with the mean shift taking out. We see there are still funny things here, right? We also see that the slope is not exactly aligned with this one. So now here's the question for you. What do we believe? Which of these statements holds? I will leave you to answer this and carry forward. Oh, there's just some code for the simulation. On closing, I want to mention that the qqplot, you always find it just for normal distribution. In principle, this can be done with any distribution, because all we did is we looked at the probability mass and we divided it into equal bins with equal probability mass. You can do that for other distributions also. It's just I think I've never seen one being used other than for the normal distribution. Okay. That ends the recording.